Okay, so we're now ready to discuss an important concept. It's called Pascal's principle. And all your hydraulic presses and hydraulic lifts are based on this really useful concept. Every time you apply brakes to your vehicles, you need to thank Pascal's principle. What it says is that any pressure that is applied to an enclosed fluid is transmitted undiminished to every point of the liquid and to the walls of the container. Okay, so if you look at just that example of when we obtain the expression P equals P0 plus rho GH, okay, we actually use this simple idea because we said that, hey, even though you were at some depth H below the liquid, okay, the atmospheric pressure did play a role in obtaining the absolute pressure, and that pressure would be fixed. That constant pressure would be fixed throughout the liquid. So if instead of the atmospheric pressure you apply another pressure, okay, in addition to the atmospheric pressure on the surface of the liquid, that pressure has to be transmitted throughout the liquid, and that's basically what Pascal's principle says. Okay, so let us look at let us look how to use this thing. Okay, especially in the case of the hydraulic lift. So if you have, say, for instance, if you have a system like this, okay, so this is all supposed to be 3D stuff. So you have a tube of fluid that goes down on one side, and then you have a second tube on the other side. You have a tube of a larger cross-sectional area. Okay, so the area here, I hope you understand that this is all a three-dimensional picture. So let's say that the area on one side is A1, the area on the other side is A2, and clearly A1 is less than A2. And let us say that you have originally everything is, let's say, enclosed, and let's say we have a thing here, we have a vehicle or whatever you want to call it, okay, sitting on top here, and here on this side we're just going to exert some force. We're going to exert a force here, okay, F1. So what's happening is that on the left hand side you're pushing the liquid, okay, and as a result of which you are exerting a certain amount of pressure on this liquid, and the pressure on the right hand side is also going to be the same. The force, however, is going to be different. So I'm just going to call this force F2. Okay, but what we know is that the two pressures, according to Pascal's principle, the two pressures P1 and P2 are going to be equal. The pressure on this side, okay, which I'm going to call P1, and then the pressure on this side, which I'm going to call P2, these two are going to have to be equal. And if they are equal, what we know is that by using the definition of pressure, which is the force divided by the area, and we apply the same to the other side, okay, these two ratios have to be equal. Now let's say that you were given F1, so we can write F2, okay, by by multiplying both sides by A2, we can write F2 as A2 times F1 over A1, okay, but write it in a form, let's just do this, let's divide this by this and multiply it by F1. Okay, we are simply redistributing the terms. So what this says is that the force on side 2 is equal to the ratio of the area of 2 to 1 multiplied by the force on 1. Now clearly in this picture you see that A2 is larger than A1, and if that is the case, okay, so if A2 is greater than A1, then what we know is that F2 also has to be greater than F1. So we're able to lift something that is really heavy by applying a force, a small amount of force on the left hand side. Okay, so you can push it with your hand and you can lift, say, a hydraulic, now you can lift a vehicle of mass, whatever, 1500 kgs, 1000 kg, whatever, you can lift it by exerting a force of 100 newtons or maybe 10 newtons or something like that. Okay, and it all depends on how the ratios of the areas are. The greater this ratio between the two areas, the greater the amount of force that you can exert. Okay, now this concept is highly used in all applications. It could be, of course, in hydraulic presses, also in your vehicles. Every time you exert a brake, all you do is you just push your foot a little bit, so you're exerting a small amount of force, but that force gets multiplied using this concept, okay, into a much larger value, and then you activate your brakes, and then they push onto the tires and then to your wheel or whatever, and then it slows down the entire system. Okay, so it's an awesome principle, and of course in engineering and everything, this principle is used a lot. So it basically says that you can get a large amount of force by exerting a tiny amount of force on one side. Okay, and in order to do this, you have to make sure that the pressure, rather not the pressure, the area on the ratio of the areas should be as high as possible.